Welcome back, my dear friends and dear students. A very good morning, good afternoon, good evening to all of you wherever you are. And this is the DADM2, which is Data Analysis and Decision Making 2 course under the NPTEL MOOC series. The total duration for this course, as I keep saying it before the starting of the class, it is for 12 weeks and we are in the 12th week. If you see the slide later on, it is we are in the last but one lecture, which is the 59th lecture, and with 60 we will wrap up this course. This total duration, as I mentioned, was 12 weeks, which is basically 60 lectures, each lecture being for half an hour, and each week we do 5 lectures of half an hour each, and you have already done 11 assignments. With this 12th one, you will complete the 12th assignment and then take the final examination. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, if you remember, in the I did mention that, again I will repeat, in the 57th lecture the time duration was much less, because it was 21 minutes, because we wrapped up the concept of artificial immune system with an example how prediction can be done from the financial point of view of bankruptcy, and did discuss about clonal selections, negative, positive, and combination of them. Then we went into artificial neural network starting the 50th lecture, and there I discussed very briefly though, and if I have not been able to explain from the actual biologist or a doctor's point of view, because that was not my intention, I wanted to only give you a snapshot. So, there are basically a neural system, they are dendrites, they pass on the information to the neurons, neurons then passes on the signals to the synapse, to the connection, they are not connected. So, they give this electrical pulses or signals, and the brain processes it. So, that can basically be analyzed using the concept of the nodes. Nodes has a sigmoidal function, they consider the weights are W1 to Wn depending on the number of nodes you have, and there are different layers, the first input layer, then the hidden layer 1, 2, 3, 4 till the output layer, and the function, and for each nodes they would be marked as 1 to 1n for the first layer, similarly 2 to 2n for the second layer, and so on and so forth, where n is the number of nodes. So, I am not considering that n number of nodes for each, the input layer, the hidden layers need not be equal. The function based on which the inputs are analyzed, the sigmoidal function, the parameters, the x values can change. And also remember, there is a supervised learning in which the feedback loop comes in order to basically give the whole neural network system a learning concept, so that it learns itself and basically fine tunes its prediction values or the output value. I would not use the word prediction, because if it is an objective function, it is not prediction. So, it gives the output in such a way that we try to find out how good or bad is. If it is not good, then it learns itself, and if it is good, based on the parameters which I have set with the threshold we have set for ourselves, it basically passes on the output into the next layer, and it goes on so on and so forth till we get the final output. Then I had also discussed the back propagation, the node functioning, and then I also mentioned very briefly, and I did mention it twice during the discussion, during the initial discussion of ANN, and also at the last few minutes of the last class, about change point detection and why it is important from the point of view of how we are trying to utilize it. So, in the matrix which we have, so the objective function was half A transpose x transpose A into x plus B transpose in x plus C. B, C's and A's values of minus plus are immaterial here, the objective function is more important. Here A, we say there is a set of non-zero vectors and is a conjugate if the following condition is satisfied. So, these are the mathematical terms which we have, such that S transpose depending on n is the size of the parameters into A into Sj, where n and j are the values depending on the number of parameters which you have, and n and j are not the same. So, generally the parameters for each node or each layer may change, but we will basically have corresponding nomenclature to discuss that. For a given set of conjugate vectors vectors S naught to S W1 W minus 1, the corresponding conjugate direction would give me for the unconstrained minimization and the maximization in which direction we should go. As I mentioned that partial derivative is generally utilized to find out the rate of change of the function, and obviously the second derivative the Hessian matrix would basically give us some information that whether it is the maximum or the minimum. Obviously, we are considering that the second derivative is greater than 0 or less than 0, it is not equal to 0, because if it is equal to 0 it will be the point of inflection. Now, the quadratic error function which will basically expand depending on the functional form. So, it will give me in which direction we are trying to minimize or maximize. I am not going to go into the mathematical detail, this is not important, because if I generally we try to basically go into the depth, then obviously a whole set of lectures about 20 to 25 should be devoted on AN, and similarly for AIS and so on and so forth. But this DADM2 is basically a set of lectures which only would basically give you a brief idea in a very simple way about the non-parametric methods of optimizations, which I have considered the AHP. I will come, you know that where AHP, TOPS, Electra, then the concept of this utility function which have been utilized, forecasting methods, so on and so forth. So, we have also considered AIS, and the ANN method is being discussed now. So, in the gradient descent method, what we are doing is basically, I will repeat it, we are trying to take the direction in which the maximum descent is there, optimization problem from the point of view of optimization problem, or we will go in the direction where the prediction is the best. So, there would be some criteria. So, in this case the actual value is x star, which we have already discussed, and if you consider from this point, so here in a 2 dimension one, either the tangent in this direction or in this direction. I am trying to draw it as simply as possible, simple. So, if it is a minimization problem, obviously you will move in that direction where the negative change is happening the maximum, and hence the descent will be the fastest. In the positive, it will be just the other way around in the maximization problem. And we will find the errors such that the errors which is epsilon would be found out depending on the difference. So, what we are trying to do is actually we find out x in the ith stage depending on how we are moving based on the fact x minus 1, and we try to find out whether this value is less than equal to epsilon or greater than equal to epsilon, but the moment it is epsilon value has been fixed from our side. So, this is the epsilon value, based on that we stop the process. Now, the residuals would be given. So, that its residual concept is something to do with the multiple linear regression concept, the errors which are there. So, we try to basically minimize the errors in the multiple linear regression concept using the rate of change of that values, which is basically we try to differentiate with respect to all the alpha, beta 1, beta 2 till beta k, then put it to 0 and find out the values. Now, here the linear combinations would be given such that based on the linear combination the scaling factor can be found out. I am not, again I am repeating, I am not going to the each and every fundamental details of the equation. I am just giving you the idea based on which how I can build up the model, similarly as I did for AIS. Now, here the problem, it was a very brief discussion, very brief discussion of ANN. Now, I am going to utilize this concept of ANN in change point detection. So, it can be solutions can be encoded with discrete variables on an optimization problem. You can basically have the complete or the approximate solution. In this case of the approximate solution, we are going to use the heuristic methods. The Metaheuristic techniques is basically, as I already said, is a kind of approximate algorithm which basically tries to combine basic heuristic methods in higher level of framework aimed at efficiently and effectively finding out the solutions. If you remember, I did mention about plant and colony optimization, simulated annealing, artificial neural network, genetic algorithm, and all these things were there. So, these are particle swarm optimization. So, these are class of problems which we have: generic algorithm, taboo search, simulated annealing, and all these things. Now comes the concept of change point detection. Now, change point detection is basically the concept which we will try to utilize from the point of view of statistics. So, consider this: you have a data set, and the data set underlying distribution, if it is distribution, means I am talking about the PDF or the PMF, or in general the distribution function, which is capital F. So, if I have a normal distribution, the distribution function is known. So, the parameters are actually a distribution function in statistics would have basically 3 parameters: alpha, beta, gamma, location, scale, and shape parameters. Now, the parameters which are there in the normal distribution are mu and sigma. Similarly, for exponential distribution, it will be alpha and a, or it can be theta a, depending on where it starts. Now, fundamentally, a data set which we have basically may have its underlying distribution is evolving with time. So, there can be 2 types of evolvement. One is the distribution per se remains same, that is, it is normal, it remains normal. If it is exponential, it remains exponential. If it is gamma, it remains gamma. If it is beta, it remains beta. But the parameters themselves change. That means, if it is a normal distribution, we are getting the normal distribution, but say for example, alpha, this mu is changing, or sigma is changing, or both of them are changing. So, our main aim in change point detection is to basically predict the values of alpha, beta, or gamma, which in the normal distribution case is the mu and sigma, and predict also when they are changing. 2 things: predict the values, predict the time when they are changing. Number 2 problem, which is one step higher, is basically the distribution function by itself is changing, that it was normal changing to exponential. I am giving you very simple examples. So, it was f1 x PDF value, now it is changing to f2 x PDF function. So, per se the parameters also changing, the functional form is also changing. So, we need to predict what is the PDF value what is changing. So, f1 changing to f2 or f2 changing to f3, and when it is changing. So, change point detection is basically would be utilized in a very simple sense, the points at which the change points are happening, and to predict the change points we will try to utilize the artificial neural network system along with one of the heuristic methods. So, this is the general background. So, consider I will come to this change point detect the problems using the data point, I will come to that. Now, why change points? So, they are effective. So, consider if you are considering the finance concept or a marketing concept or the flow concept of fluid, whatever it is, a heat movement through conductors. So, if suddenly if the heat change is not happening because there is some congestion, fluid flow is not happening because there is some congestion, the pressure is increasing, decreasing, the distribution by itself or the rate of change is changing. So, you want to predict it. So, in this case of economics, finance, this change point detection is heavily used. So, why? Because the effect on the marketing factors could be there on interest rate. We want to find out the rate of change of the interest rate, the gross domestic product is changing, inflation rate is changing, unemployment rate is changing, we want to predict when they are happening. These factors make the exchange rate. So, these effects which are happening for the exchange rate, because our main aim would be to find out the exchange rate for this study. Because exchange rates are highly volatile and fluctuating through, thus making exchange rate inherently noisy, non-stationary and chaotic, and we want to basically find out when and where the changes are happening. Exchange rates are not homogeneous, that there are maybe structural breaks. So, change point detection, another word for change point detection is structural breaks. So, in many of the books if you study, obviously in the area of statistics, the concept of structural breaks or change point detection are chosen interchangeably. Now, there are different tests for change point. I will just mention them without going to the mathematical details, because not as a statistical course. So, there you have the Chow test, which is the linear models. Then you have the regression methods are basically when they are utilized, you can use the linear models of the Chow test, because we remember in regression model the model is linear in the sense of the parameters. So, it can be alpha into x square, depending on x square has a distribution which is a normal distribution. If you remember, amongst the 7 different assumptions in multiple linear regression, one of the assumptions is basically the dependent and the independent variables all should be linear and they should be independent also, because if they are not independent, then that concept of this covariance and all these things would be coming. These were among those 7 set of important assumptions. You have the parametric methods also, the likelihood ratio test which are there. For the non-parametric methods, we have the Pettitt test, which is based on a Mann-Whitney type statistics, depending on non-parametric values happening at the rate such that the changes of this parameter values are non-linear in nature. So, they will check for the changes in the underlying distribution function of the subgroup. So, what we will try to do is that technically it may be possible that the distribution f of x or f1 of x is changing, and as it is evolving, it may so happen that the changes are happening randomly. Obviously, they would be happening at the random points which we do not know and we want to predict at the time. So, they would basically given as 2 areas which I discussed, the change of the parameters or change of the functional form itself. Now, if the underlying distribution function you divide into subgroups. So, today I found out, say for example, this foreign exchange is same and it does not fluctuate. Say for example, I want to predict it 1 year down the line, but in between that 1 year it may have changed and again come back to its original self. So, subgroups are important to find out, predict that if I basically have the consider from the point of view investment, if you invest and you want to go enter the market or come out of the market in between that 1 year. So, what are the subgroups, in the subgroups what are the changes and what points they are changing, what is the rate of change of the interest rate, such that I do not enter the market where I have to pay a higher fee, or I do not come out of the market where I get a lower fee. That means, I want to basically minimize my loss. In the absence of knowledge of time series parameters, in this case for the mainly for the exchange rate, because exchange rate are dependent on many things. It can depend on the GDP, it can depend on the gold price, petroleum price, inflation, interest rate of other countries, population, whatever it, we do not have the parametric form. Hence, as parametric forms are not possible, we will try to utilize neural network concept. Along with that, we will also try to utilize some of the heuristic methods in order to do the optimization. Optimization means the prediction of the change point as good as possible. Now, here is basically what I told you very simplistically verbally. Here is basically the concept of the change point and the Pettitt test. Consider a sequence of random variables are x1, x2, x3 till xt, mark the word capital T in the suffix. Now, what we have is basically the time. So, I measure x, I find out x with a suffix 1 at time period 1, x2 at the time period 2, so on and so forth. So, then the sequence is said to have a change point tau if xt, that means t starting from 1 to t small tau will have a common distribution of f1x. This n1 does not mean have any significance with 1, 2, 3, 4 in the time series, is basically a functional form, and starting from tau later on, that is tau plus 1 till capital T, there would be another distribution f2 such that f1 and f2 are different. That means, I am considering per se the distributions also changing, I am not considering per se the parameters values are changing. So, it is a simplistic form, I am considering that normal is changing to exponential or exponential is changing to gamma, so on and so forth. Now, if I have, so we will try to basically have the Pettitt test as an hypothesis testing point, where h naught would be the case that if tau is equal to t, there is no change. For the time period which I am considering, if there is no change, the h naught would be ratified or will agree with h naught depending on the test rule, and if h a is ratified, that means h naught is rejected, we will find out that at point tau where the point is changing, we will mark that as the change point. Obviously, it may change, you may say that there can be many taus in between capital T. So, it can be tau 1, tau 2, tau 3 till tau n or tau k, yes it is possible, and we can find out using the Pettitt test accordingly. So, we will basically check, very simply mention the algorithm based on which you do. You will calculate the rank. Spearman rank is basically the one of the correlation coefficients we used. Spearman ranks would be found out, associate with each random variables, and we will find out the sum of the Spearman rank coefficient. Then we will basically find out the running sum of them, Spearman ranks. For the corresponding Mann-Whitney rank would be found out depending on the formula of u t for j is equal to 1 to t minus 1 for all the points where we are finding on the Spearman rank values. You will calculate the values of Mann-Whitney ranks by finding on the maximum of them, and find this, I am just mentioning the bullet points of the steps. So, you will find the value of j where the maximum of the statistics occurs, and that gives us the estimated change point of the sequence. So, the sequence would be divided into two subgroups, one from t is equal to small t is equal to 1 to m, and another would be from m plus 1 to t. So, it will be divided into two groups, the first group and the second group where the changes are happening. So, if I have this is the change point. So, let me mark it with a different color. So, this is the change point. So, we find out. So, the time period. So, this is actually capital T, this is from 1 to tau, this is tau plus 1. I have tried to draw it as simple as possible as you, and this is from 1 to tau. So, there can be more. So, this is one subgroup. This is one subgroup, and similarly this is one subgroup. Based on that, we can do the calculations. In step 5, according to the standard rank theory, we will try to find, we will under the null hypothesis, we will consider there is no change, and as t becomes large, we can approximate using the normal transformation. So, here is the normal transformation. So, this is the expected value and the variance. So, it is basically exactly the same way. So, you have basically in the z test what you do, x minus mu by standard deviation of x. So, I think I should write it like this, so it is easier. So, this is the expected value of x. We are using this concept. That is the central limit theorem, not in the exact central limit theorem, but the concept of central limit theorem would be utilized. Now, considering the two-tail test, the two-tail means on the left hand side and the right hand side, and the alpha values which are there. So, alpha values means alpha by 2, alpha by 2. So, this is 1 minus alpha. One tail test would be either on to the left or the right, depending on that you can find it out. So, if you remember in statistics, if you have obviously done, or is somebody who has done DADM1, we considered the concept of hypothesis testing greater than type, less than type, and not equal to, and based on that we have 3 different rules, which were basically coming from the concept of interval estimation. Now, the parametric forecasting methods which we generally have, which we will try to basically incorporate in the ANN, these are not to go, I am just mentioning them. So, you will basically the ARMA GARCH method, which are in the forecasting method we did consider very simply the concept of halt linear and halt-Winter method, halt method, then moving average, exponential moving average, adaptive moving average. So, based on that we will try to predict where the prediction would happen depending on some error part and its regressed values to what level you will go. So, if you are predicting basically for yt, you can go for regress to yt minus 1, yt minus 2 and so on and so forth. Again these explanations I am omitting, they are not required because the main focus is for the ANN, how you can utilize that. For the ARMA-GARCH method, obviously the log likelihood function for the prediction models can, for that, this is basically I am considering the log likelihood function. Likelihood function, it will be converted to log likelihood function. The best estimates for sigma, sigma hat and y, which is y hat, would be found out using these models, where the hats are the estimates of the underlying parameter values which we are trying to utilize. Now, we will basically utilize the model for the ANN1 using these. What are these? I will come to that later. We will consider the neural network which will be trained using the conjugate gradient method simply as it is developed in the ANN literature. We will use the change point detection for the neural network combining two different methods. One is the genetic algorithm, one is the simulated annealing. So, it will be mentioned as NN, GA, NN, SA depending on NN being neural network, the first two words, and GA and SA being basically for genetic algorithm and simulated annealing. Now, you will basically have the neural network with the conjugate gradient method utilizing both GA and SA. That means, in the first stage we are only utilizing the conjugate gradient method. In the second method we are only using the ANN with the G and SA, and the third stage we will combine the existing conjugate gradient method being refined more by the use of genetic algorithm and simulated annealing, and check how the results are better or worse. Now, with the change, that was basically without the change point detection. Now, with the change point detection concept, again we utilize the change point detection along with the gradient one. So, I will repeat this overall picture again. So, in the change point detection with those Pettitt test and all these methods which we discussed, the rank coefficient and all these things, we will consider using the conjugate method. We will use the change point detection methodology using the GA and the SA, and then basically combine the change point detection methodology with the conjugate method along with GA one time and SA one time. So, overall picture is like this. No change point algorithm being utilized, we will use the gradient descent conjugate gradient method, then we will use the concept of G and SA separately and then combine them. In the change point detection, the algorithm being utilized using the statistical point of view, we will use the conjugate gradient method once, separately we will GA and separately we will SA and then combine them accordingly. So, with this I will end the 59th lecture, and in the 60th lecture I will try to give some results for this methodology, how we utilize them. Have a nice day and thank you very much.